Betelgeuse, a red supergiant star in the Orion constellation, is one of the brightest stars in the night sky and is easily recognizable due to its distinctive orange-red color. The star is located approximately 640 light-years from Earth and is one of the closest red supergiant stars. In 2019, Betelgeuse made headlines across the globe when its brightness started to visibly fade. Since then, this prominent star has brightened, faded, then brightened again, perhaps resuming a less functional condition. However, more dimming is possible at any moment, revealing that Betelgeuse will become a supernova one day, but no one knows precisely when. James Webb Space Telescope data about Betelgeuse's explosion is pretty shocking. What information was revealed in this data, and how does it affect the planets? Stay tuned to the end for all the details. Betelgeuse is a massive star with a size that is estimated to be between 700 and 1400 times larger than the Sun. The size makes it one of the most prominent stars known to exist, and its enormous size is also why it shines so brightly in the sky. Despite its size, however, Betelgeuse is not a very dense star. It has a much lower surface gravity than other stars. Betelgeuse is a pulsating variable star, meaning its brightness changes over time. The star's brightness varies between magnitude 0.2 and 1.2, which makes it one of the most easily noticeable variable stars in the night sky. The period of these brightness changes is approximately 420 days, and the cause of these changes is believed to be closely related to changes in the star's internal structure. Betelgeuse is also known for its distinctive shape, which appears as an oval or oblong shape in images taken by telescopes. This shape is believed to result from the star's convective solid activity, which causes the material to rise and fall within the star. This convective activity also contributes to the star's variability, as the movement of material can cause changes in the star's brightness. It will interest you that most prominent stars are named in Arabic. This is because Arabic astronomers and astrologers dominated throughout the Dark Ages in Europe. Betelgeuse can be translated to the Arabic phrase, the armpit of the giant. The giant is obviously a reference to Orion. However, other writers may see Betelgeuse as a hand or even a shoulder. Betelgeuse, whose origins are obscure, is often seen near Orion's right shoulder in antique star atlases. It is usually shown with some anatomical link, since Orion is often connected with a giant, a warrior, a hunter, a deity, or an anthropomorphic or animal character in ancient stories. Using the Hubble Space Telescope and other observatories, astronomers were able to confirm that the senior star indeed lost some of its surface in 2019. An event of such massive mass ejection from a star's surface has never been seen before. Now, something is happening that we don't fully grasp. Harvard and Smithsonian Center for Astrophysics researcher Andrea Dupree made this claim in a press release. To my knowledge, Hubble is the first instrument capable of directly seeing this phenomenon and resolving surface features. As time passes, we can see how stars change before our eyes. If our Sun were Betelgeuse, its enormous diameter would reach beyond Jupiter's orbit. Betelgeuse, which is just 10 million years old compared to our star's middle-aged 5 billion years, might burn out in a supernova explosion in the next 100,000 years, as is typical for stars of its sort. A supernova is a powerful explosive event that occurs when a star completely runs out of fuel and collapses on itself. Betelgeuse is expected to eventually undergo this process. When it does, it will likely become one of the brightest and most visible objects in the night sky for several weeks. The Great Dimming of Betelgeuse occurred between November 2019 and April 2020, resulting in the second closest red supergiant, Betelgeuse, experiencing its largest ever decrease in brightness. Data from the VLTI gravity interferometer show that the star's angular diameter in the K-band continuum did not change considerably between January 2019 and February 2020. Images captured by the VLT Sphere telescope reveal the star's southern hemisphere is obscured. Betelgeuse's great dimming may be explained by a combination of cold photospheric patch and a dusty cloud in the line of sight based on further optical photometric measurements. It's possible that the former caused the latter. Because of ALMA's sensitive detecting mechanism, findings may be more accurate than ever. This is because the radio waves detected by the ALMA antenna array may pass through the gas and dust that blocks the views of other telescopes. 66 antennas make up ALMA, and the telescope dishes may have sizes anywhere from 7 to 12 meters or 23 to 39 feet. Each dish's reflecting surface collects light from a distant astronomical object and directs it towards a detector, which analyzes the intensity of the reflected rays. Once the signal has been digitized, it travels across 16 kilometers or around 10 miles to an operations support center, where the data from all antennas is combined to provide a complete picture. The millimeter in ALMA refers to the wavelength of the radiation picked up by the telescope dishes. These waves may be found between infrared and radio frequencies in the electromagnetic spectrum. Surfaces on the dishes are so precise that dimensions to the nearest 25 micrometers may be determined with high precision. In addition to the localized temperature rises that make Betelgeuse's surface uneven, which were previously detected by VLT, ALMA has now seen them. The red supergiant star's lower chromosphere emits the sub-millimeter wavelengths that ALMA is sensitive to, providing a view into the star's interior. The mass expelled by Betelgeuse's explosion was almost 400 billion times that of a typical coronal mass ejection. As a result of losing so much of its mass, the star became surrounded by a cloud of dust and developed a vast, chilly depression on its surface. Consequently, Betelgeuse became much dimmer, and the alteration was noticeable even to novice astronomers. This will be the most visible sign that Betelgeuse has reached the end of its existence, at least on a cosmological timescale. However, people need to predict precisely when it will go off. It may occur tomorrow, or it might happen in a million years. More than 1 million miles broad convective plume boiling up from deep inside the star might have generated the colossal outburst. It caused shocks and pulsations that blew the chunk of the photosphere away, leaving the star with a big cold surface area underneath the dust cloud created by the cooling portion of the photosphere. Curious to know if our planet will be destroyed by its supernova? We will tell you more. The Earth is too far from Betelgeuse for any potential destruction of life here to be a concern, even if the star were to explode. A supernova can only destroy Earth if it is closer than 50 light-years away, while Betelgeuse is more than 14 times that distance. Although everyone on Earth at the time will see a brilliant light in the night sky. Dupree warned that although spectacular, Betelgeuse's firing a portion of itself into space doesn't imply the star's end is imminent, and that the dimming was proof of a more minor explosion that had previously happened. Indeed, the star is making a gradual recovery after the blast. According to Dupree, Betelgeuse is still acting quite strangely right now. The inside is kind of bouncing. After Betelgeuse totally detonates, it will be visible from Earth during the daylight. As a result, scientists will keep digging deeper into the explosion's data to get a better understanding of what transpired. To get a better look at the supergiant star fragment hurtling through space, scientists decided to utilize NASA's James Webb Space Telescope. We trust the JWST to provide more details and more explicit images to assist scientists with this research. Now, over to you. Are you looking forward to the Betelgeuse supernova? Or would you rather it happen in 1 million years from now? Let us know your thoughts in the comments section below. We hope you enjoyed watching this video. If yes, we're sure you would like this next video here. Thanks for watching.